Hi, my dear students. Good morning to everyone. Today, I came in front of you with a new concept, that is trigonometry. So, in last class, we were discussed the content which is related to trigonometry, like a naming of sides of right angle, defining trigonometric ratios. Along with that is a concept of complementary angle of trigonometric ratios and identities. We were made in two parts, whole concept of lesson. If you are not gone through that is, I given the description below, there is a link of those two concepts. Please follow it. Okay, in today's class, I am going to discuss regarding to the on the basis of naming of right angle triangle and at the same time defining a trigonometric ratio based concept. Do these, try this, and as well as example questions I am going to discuss now. So, myself, Hatiram. Okay, so let us start today's session with the new questions which are given in do these. Okay, so in the do these, if you see, there is a questions are given on the basis of naming of sides, identify hypotenuse, opposite and adjacent sides of a triangle. So whenever there is a question you have seen like this, I told you to remember, if there is a right angle, first you identify right angle, opposite is called as opposite side. Okay, the side which is opposite to right angle is called opposite side. Next, the side which is this, if you will take as here, there is a two angles are given, either P is angle or R is angle, but in the question level for angle R. So for angle R is nothing but this one. So first you write the hypotenuse name. What is the hypotenuse here? PR is a hypotenuse. Okay, next what is that? R is angle. Angle's opposite is called as opposite side. So it is nothing but PQ is called opposite side. Next, the line or side which is joining the angle other than hypotenuse is called adjacent. That is nothing but RQ or QR. So it is a adjacent side. Okay, next, in the second question, if we see, there is a right angle at Z, so we can say the hypotenuse is nothing but for angle X. For angle X, for second question, answer is, so here hypotenuse is XY. Okay, next, if you see angle X whose opposite is called as opposite side. So it is Y and Z is called opposite side. Next, the other side which is there left is ZX is adjacent side. So next, in the, if you see second one, that is for angle Y, if you will observe properly, if this is becomes angle, let me erase this is so that you can get clarity somewhat. So if you see, so if you observe, for angle Y, hypotenuse is same, that is XY is becomes hypotenuse because right angle opposite called as hypotenuse. Next, angle Y opposite is called as ZX is called as opposite. The side which is adjoining with Y is nothing but YZ is become adjacent side. Okay, so in this way we can name the sides of a triangle. Okay, my dear students. Next, if you see the next question, write the length of hypotenuse, opposite and adjacent sides for a given triangle. So for angle Y, C and angle A we have to write it. But if you observe, there is a two sides only given, third side is not given. When hypotenuse is given and other side is not given, I told you to find easily in one method, but we will do process here. So from triangle ABC, so Pythagoras theorem says that what it is says, hypotenuse square is equal to, it is square of sum of squares of adjacent sides of a right angle, that is AB square plus it is a BC square. Hypotenuse is given 5 square, which is equal to, AB is unknown for us, it is not known, BC is given 4, it is 4 square. So 25 is equal to AB square plus 16. So 16 if you transfer, it is become minus 16 is equal to AB square. So AB square is equal to, it becomes 9. Then AB value is square root of 9, simply called 3 centimeters. So AB value how much more? It is simply 3 centimeters. So after knowing AB, for angle C, what we can write the side ratios is, hypotenuse is common, that is hypotenuse AC is equals to, it is 5 centimeters. As C is angle, C's opposite side is nothing but 3, so opposite side which is equals to, that is AB, name it as a 3 centimeters. So next, adjacent side. So adjacent side we can write as the BC, which is nothing but 4 centimeters. Okay. Next, for angle A, okay, second one, this is first one. Second one you can see, for angle A, what we can write? Let me erase that first. Okay, done. Next you can write now easily. As you know, that is angle A is there, then this is becomes hypotenuse, it doesn't change. Hypotenuse AC is equals to, you write 5 centimeters. Angle's opposite is 4 centimeter, that is opposite side, that is BC is equals to, simply called as the 4 centimeters. Next, adjacent side is equals to, that is 3 centimeters. Okay, I hope it is clear to you, right? So copy the answer, pause the video and copy the answer. Next question. Do this question. Here you can find, there is the question is given as like this. Find sin C and cos C and as well as tan C for the adjacent triangle. In adjacent triangle, like a previous question, here also there is a two sides only given, third side is not given. So first we will find the third side with the help of given. So they were given A, B and this is a C, angle is at C, hypotenuse 13 centimeters and there is adjacent is 5 centimeters. This is opposite, known to us. So by the Pythagoras theorem, what we can say is AC square is equals to AB square plus BC square. So AC value 13 square is equals to, AB is unknown, that is AB square only write it, plus BC square is 5 square. So 13 square is 169 and 5 square is 25. Bring it to this side, it will become 20 minus 25. that is equal to AB square. So it is subtraction 144 is become, so AB square value. Then if AB square is that is, then AB value is square root of 144, which means 12 centimeters. Okay, so AB value also got it, that is 12 centimeters. So for the angle C, opposite side is becomes angle is C, then opposite side value is 12 centimeters. Okay, hypotenuse is becomes 13 centimeters. Adjacent side is becomes 5 centimeter. Now write sin C. Sin C, I told you to trick, remember, in this way. Okay, OAO HHA. This logic I told you in the last video. Okay, OAO HHA. O by H is nothing but opposite by hypotenuse. That means sin C. Sin C is opposite by hypotenuse. That is 12 by 13. Okay, cos C is nothing but adjacent by hypotenuse. That is 5 by 13. Okay, like a tan C, I told you that it is easy. O by H, opposite is 13 by hypotenuse is 5. So in this way we can able to give the answer for this particular question 1. Okay, next question. If you see second question, in a triangle XYZ, Y is a right angle and ZX is 17 meters, YZ is 15 centimeters. Actually this should be in a centimeter only. Okay, so find the sin X, cos Z, tan X. So for the second question, first draw a triangle. So by taking a Y is right angle, then other two side you can place any as your wish. Okay, Z and X you can place, or either X and Z also you can write it as your wish it is. So YZ is 17, YZ is 17, ZX is 17, not YZ. So it is Z into X 17 centimeters rated, but not in meters. So here is YZ is 15 centimeters. Like a previous question only, I am giving direct step to you. So YX is nothing but under square root of ZX square, that is hypotenuse square, minus the side square ZY square. So if you want to process from the previous two questions, I made it solve the same method. You can do it in that way. 17 square minus 15 square. 17 square is 289 minus it is 225. If you subtract it is, simply you will get answer as under square root of 49. Okay, so 49, right, so we'll see 289 minus 225, it is a 4, it is 6, sorry, it is not 49, it is a 60, sorry, 4 we are getting, 64 we are getting. So let us try to erase this. So 64 we are getting. So under square root of 64 known, what is the value? Tell me, ma. It is 8 centimeters. So one of the side is 8 centimeter, we got it. So as you know the 8 centimeter answer here, then the questions asked is this is 8 centimeters. So sin X, so X is this angle, opposite is 15 and adjacent hypotenuse is 17. So 15 by 17. Next, cos Z. See, adjacent is nothing but for Z angle it is 15. So cos Z is 15 upon 17. As we know, x and z are complement, then sin x and cos z should be equal. This is already we made in the previous concept. We were concluded this part. Next, tan x we have to write. So tan x if you will do it, opposite for the x is 15, adjacent is 8. So this is what the answer for this particular question. Okay, next there is another question is given, similar mode, you try that. Okay, same method, there is no variation. Okay, my dear students, solve this and give me answer in the comment box. Next, try this question. In a right angle triangle ABC, right angle at C. So in a right angle triangle ABC, right angle is present at C, then you can take this is A and this is nothing but B as your wish. But they were given not sides, relationship between the sides are given, then we have to find sin A and tan B we have to find. That is BC plus CA is equal to 23. Similarly, BC minus CA is given that 7. So, if you subtract, then you are getting a 13 minus, this is borrow, take it 1 and this is become 13. 13 minus 7 is 6 and this became 1. CA minus CA 0. 2 BC values are 16, then 1 BC value is 16 by 2, which is equal to 8 centimeters. Now substitute this value either any one of the equation 1 or 2, so that we will get from equation 1 we will get 8 plus CA is 23. Then CA is equals to 23 minus 8, which is equals to 15. So CA value we got it as a 15 centimeters. Okay, so CA is a 15 centimeters we got it, and BC we got it as a 8 centimeters. Then third side is hypotenuse, that is AB square is equals to BC square plus CA square. You can use Pythagoras theorem. Then if you solve, AB square is equals to BC is 8 square plus CA is 15 square. So 64 plus it is 225. If we will add, it is a 289 like a previous question exactly. There is no variation actually, right? So without any variation we got it. So AB is square root of 289. 289 is a perfect square root of 17. So answer is 7 centimeters. Now given questions are sin A. So 17 is hypotenuse. 7A opposite side is 8. Okay, by hypotenuse is 17. Tan B is nothing but this is opposite is 15, adjacent is 8. So 15 upon 8. So no units will exist because it is a ratio of similar quantities, right? Yeah. Think and discuss related questions. So in think and discuss related questions, if you properly observe some conclusions we can made, it is what the conclusions. So what does sin x is 4 by 3 exist for some value of x? Is it exist or not? They are asking. Absolutely no, we can say. What is the answer for this? Is a no, it does not exist. So sin x is equals to it is 4 by 3. Sin x is equals to 4 by 3 does not exist. Okay, does not exist for some values of some value of angle x. What is the reason? The value of sin x is lie in between the 0 and 1. The value of sin x or sin theta always lies between 0 and 1. Okay, or we can say sin x, or we can say that sin theta is equal to opposite by hypotenuse. So in a triangle, hypotenuse is always greater than opposite will be. That is the reason also we can say it is always less than 1. Hence, sin x is should be less than or equal to 1, but greater than 1 not possible. Why? 4/3 ratio is greater than, it is greater than 1. So sin x will not be greater than 1 it is. Right? Second question, if you see. Second question, if you see properly, what is they were saying? The value of sin A and cos A always less than 1. Why? So why they will be lie less than 1 they are asking. So take a circle with 1 unit radius. Okay, take a circle with 1 unit radius. Then it will become, as the radius is 1, then what we can say? We can say simply that is radius of this circle is becomes 1. Okay, then one more line draw, that is as like a x and y axis, and take it as a center is origin. Take its center as a origin and draw a 1 unit line. Okay, so it will become origin 0, 0, and let us take this arbitrary point, any p point like a, b. Okay, any point you can take it on the circle a, b. Then this is becomes opposite, that is b. This is becomes adjacent, that is becomes a. It is making some angle theta with a reference axis x. Okay, this will becomes y. This is a minus x and this will become minus y. So as we took the length, it is nothing but 1 unit. Then if you see sin theta, say as opposite by, it is nothing but hypotenuse is 1. Okay, so it is a y coordinate. Similarly, cos theta, if you take it, then it becomes adjacent by 1 hypotenuse, that is a x coordinate. It becomes x coordinate. Now, if you move along the circle 360 degrees, then at this point, if you observe properly, let me change the pen. At this point, if you see, let us say this is a, on the x-axis it will become 1, 0. Means if theta is 0 degrees, then the value is becomes 1. For what? It is for the sin theta. If you say sin 0 degrees, sin 0 degrees is opposite side is not there, so it becomes 0, and cos 0 degrees is becomes 1 here. I hope you can understand, right? This is a point on this x-axis. A value is nothing but 1 unit will become, B value will becomes 0. So theta is becoming 0, sin 0 is 0, cos 0 is becomes 1. At B, if you will see, it is 90 degrees. At this point on y-axis, x is 0, y is becomes 1, because 1 unit length here, from here to here it is a 1 unit length along the y-axis. Then if I will say sine, okay, 90 degrees, so y coordinate, no, y coordinate how much? 1. So cos 90 how much? That is x coordinate. X coordinate how much? It is 0. Similarly, if you will write it, okay, if you will write it, the values. So here in this case, here x is minus 1, y coordinate is nothing but 0. Means up to here it is 90, then up to here it is 180. So sine 180, because y coordinate is became 0, then x coordinate how much it became? X coordinate is becomes minus 1. So sine minus is minus 180. Next, if you see 270 degrees, from here to here 270. So here it becomes x 0, y minus 1. Then sine 270 degrees, which is equals to, it is sine is which coordinate? Y coordinate. Y coordinate is minus 1. Okay, cos 270 is becomes how much? X coordinate. X coordinate how much? 0. Similarly, if we write for 360 degrees, sine 360 degrees, x is becomes y coordinate is becomes 0, and cos 360 degrees is becomes 1. So if you observe now the whole cycle 360 degrees, so sine is maximum 1, minimum minus 1. Cos also same thing, maximum 1, minimum is minus 1. So sine value is always less than 1 will be. Okay, is it clear? So if you see here, sine, it is always how much will be? Less than 1. It does not exist more than 1. So this is what the question is. Sine A and cos B always less than 1. Why means this is a reason. Okay, I hope you satisfied with this answer. Sine values, sine theta is greater than or equal to 1, less than or equal to, it is less than or equal, is greater than or equal to minus 1, less than or equal to 1. Cos also will lie in the same thing. The next question is what is the value? Tan A is a product of tan and A. It is a false statement. What we have to say here? False it is. No, the reason is tan A is abbreviation of tan tangent of angle A. So tan A is not a tan and a product of A. It is abbreviation of tangent of angle A. So tan and A separate. If you will separate, there is no meaning for this. Is it clear? So it is not product of tan and A. Next, here there is an example question. As you are familiar with the previous questions, and do this and try this, you can able to solve these questions very easily. What is the question is given? Question is very simple. That is, they were asking that tan A is equal to 3 by 4. Then find the other trigonometric ratios of angle A. So if you take any triangle, so in the triangle, let us take, this is nothing but A side, this is a B, and this is a C. So this is became angle now. What is the given here? Tan A is equal to 3 by 4, which means opposite side by it is adjacent side. So opposite side of A, opposite side of A is nothing but 3. See, 3 is a ratio, right? It may be multiple of some integer. Then I can say it is maybe 3k, where k is some integer. Why? If my ratio is 6 by 8, then it may cancel now 2 table. So as like this, if may it is multiple, then you would take it as some k. If you remove the ratio form, then we have to write like this. Then adjacent side of A is 4k. Then we have to say it is 3k, it is 4k. So find the third side AC. So AC square is equals to AB square plus it is a BC square. What is the answer, ma? AB is nothing but 4k square whole square plus it is a 3k whole square. Simply it is a 16k square plus 9k square. We will get as a 25k square. This can be written as a 5k whole square. So AC square value is this is, then AC is under square root of 5k whole square. Square root gets cancelled, it becomes a 5k. So hypotenuse is a 5k. Let us try to write, again draw the triangle so that you can understand now. So if you draw one more triangle with the known sides, so with the known sides, CA, B, C. This is 3k, this is 4k, and this is a 5k. Angle is this is. What is the question given? Now see that. Find other trigonometric ratios of angle A. So all the trigonometric ratios we have to write it other than tan A. What is the first one, ma? T ratios in that first one is sin A. Sin A is opposite by hypotenuse. 3k by 5k. Anyway, kk gets cancelled. 3 by 5. Second, cos A. I am writing directly now. 4 by 5 adjacent upon it is hypotenuse. Okay, third one, cot A. Reverse of tan, that is a 4 by 3. Okay, fourth one, cosec A. Reverse of sine, it is a 5 by 3. Next, fifth one, it is a sec A. Reverse of cos, 5 by 4. Okay, I hope it is clear to you. Next question. Example 2. If A and B are acute angle such that sin A is equal to sin P, prove that angle A and P are equal. So two trigonometric ratios are equal, that is sin A is equal to sin B for two triangles, then their angles also equal, we have to prove it is. Remember, these all are the conclusions we will use in the further section of our classes. Okay, this is one triangle, you take it like this, A, B, C. Another triangle you take it as this is nothing but P, Q and R. Given that sin A is equal to sin P. This is A, this is become P. From this is sin A, write it. Sin A is opposite BC upon there is hypotenuse AC. Sin P, write it. Sin P is nothing but opposite RQ upon the hypotenuse is nothing but RP. So if two trigonometric ratios are equal, then the ratio of sides are also equal. That means BC by AC is equal to RQ by it is hypotenuse is RP are also equal. So I can say that if the side ratios are equal to some constant k, then if you interchange their sides like a BC upon RQ also equal to AC by RP. Simply I interchanged this position. I did done the only one thing, that is okay, it is equal to k. As we know, two side ratios, okay, as like this side ratio is correspond to this is correspond to this is, then we will find if in case the third one like AB and PQR ratios are also equal as like this, then we can say these two triangles are similar triangles. If two triangles are similar, then their angles, corresponding angles are also equal. So on that basis, I want to solve this particular question. Okay, is it clear? So what I am going to do is I'm going to do somewhat calculation here. I don't know third side ratio. I want to know the third side ratio as like this. So what is the third side in the triangle ABC triangle? Okay, from ABC triangle, third side ratio like AC square is equals to AB square plus BC square. I want AB square. Then AB square can be written as AC square minus it is a BC square. Then AB can be written as under square root of it is AC square minus BC square. Similarly, what I want to tell you is from the triangle PQR. Okay, triangle PQR notes. PQ is as like hypotenuse PR square minus it is RQ square. Okay, then make a like divisions of these two. I want to divide these two also, like AB, this is equation 1 and this is equation 2 to take it. So equation 1 by 2 if I do, that is AB upon PQ is equals to under square root of AC square minus BC square by under square root of PR square minus PQ square. So AC, see here in this onwards, BC value can be written as from here onwards, BC can be written as AC into K. I can write no KAC. See, I will change the color of pen to show you. So I will do product of this is. Similarly, RQ can be written as a K into RP. So that is AC can be BC can be written as it is KAC means K square AC square by under square root of RP square minus here RQ, sorry, PQ I think so. This is RQ not. One moment please. It is sign is opposite RQ by it is a PR. Yeah, it's correct. So here PQ we want. PQ is nothing but a denominator RQ. PQ is nothing but this is somewhere. One moment please. Sin P is equals to this is P, this is Q. Opposite by this is RQ can be written as here I think we made mistake. Hypotenuse is nothing but hypotenuse is PR square minus the RQ. This is RQ square correct only. So this is RQ. So RQ is nothing but K square RP square. Okay. Then here AC square here RP square take it as a common. Then what we can write AC square of 1 minus K square by RP square of 1 minus K square. So AC square under square root will come out AC, RP square under square root will come out, that is RP. So what is left? 1 minus K square by 1 minus K square. Okay, 1 minus K square by 1 minus K square is left. So both are gets cancelled. Then here what we got it is AB upon PQ is equal to AC upon RQ we got it. Okay, so this color is somewhat bold is there. I want to reduce the boldness. Okay, done. Now see, previously we have a relation that is BC by PQ. BC by RQ is equals to AC by RP. Now what we got, one more relation, AB by PQ. Now third ratio also equal to as like this, means three corresponding ratios. AB is equal to PQ ratio. So if three side ratios are equal as like this for any two triangles, corresponding side ratios are equal, then corresponding angles are also equal. So here side ratios are equal, then their corresponding angles are equal because triangle ABC is similar to triangle PQR. Anyway, you will get this lesson in this 10th class itself. Okay, so ourself here angle A is corresponds to angle P are also equal, hence proved. Okay, I hope it is clear to you. Next, one more question. If not clear, please go through the again, watch the video, you will get clarity on it is, right? So example 3, consider PQ or triangle. There is a PQ is given 29 units, QR is 21 units. Okay, then we have a given angle at vertex P is nothing but theta, then we have to find this. So if you have seen the previous video of concept, you can clearly say that is a sine squared cos squared theta plus sine squared theta is 1, and moreover the minus is becomes another answer will come here. Okay, so see, there is a two sides are given, third side we have to calculate. Q is right angle, I am taking P, this is R. So PQ is nothing but this side. How much they given? 29 units. Okay, QR is this side. Okay, they given 21 units. Okay, we have to find this third side. If you want to find third side, okay, so what we can do, hypotenuse square, that is a PR square is equals to, it is a PQ square plus it is a RQ square. PQ is simply PQ 29 units plus it is nothing but we will call as a 21 units. So if you will do the square of it is, wait, PQ 29 units, that I think there is a question has some mistake. Okay, PQ is 29, in the sense PQ is became this is, okay, question has some mistake. The angle is at Q they were given, I took vertex as a this is, so question not having mistake, myself I did mistake, wait moment. Okay, angle at Q is there, I took it is as a right angle. So it is a Q theta. So right angle at R is there. I have to take right angle here. Okay. Then other side you can take it as your wish. As you can take any side. So it is nothing but the P. Right angle at R. This is what I done mistake. So Q is that is a PQ is 29 units, and QR is this is adjacent 21 units. So other side we have to find, that is PQ square is equals to PR square plus RQ square. So it is 29 units square minus there is a RQ is nothing but 21 unit square This is we don't know, PR square. So 29 square is a 529 square is a 841 841 is equals to PR square plus it is a 441. Bring this side. 841 minus 441 is equals to PR square. So it is ultimately equal to 400. That is PR square. Then PR value how much? PR is square root of 400 is equal to 20. Okay. So we got it that triangle clearly with three different sides. What? P, Q, this is R. 29 units, 20 units, 21 units. The first question is they were asked cos square theta plus sin square theta is how much? So cos square theta is nothing but as here angle is at Q, cos is adjacent 21 upon 29 whole square because square is given. Plus 20 upon 29 whole square. So 21 square by 29 square plus 20 square by 29 square. Why sir? If there is a b whole power m is there, then we have to separate as a power m, b power m. Similarly here we were separated the square. 21 square is 441 by 841 plus 400 by 841. Both are like fractions. Simply what we can able to do is we can add the numerators directly. That is 441 plus 400 upon 841. So 841 by 841 which is equals to simply 1 means cos square theta plus sin square theta value is nothing but 1. Keep with you this answer. We will use in further session also about this. Next cos square theta minus sin square theta they are asking. So cos square theta plus sin square theta value if you want to know, then what you do is simply I will change the color of pen. So here second question is cos square theta minus sin square theta. Cos square theta already we know that is 21 by 29 whole square by 20 by 29 is a sin square theta. So if you will do that squares, that is also known for us 441 by 841 minus 400 by 841. So simply it is 841 LCM 441 minus it is a 400 which is equals to 41 by 841. Don't cancel 41 by 41. It is answer is that cos square theta minus sin square theta is equals to 41 upon 841. Okay, so this is what our answer is. Okay, my dear students, with this we were completed numericals which are based upon do these, try these, and as well as example questions which are related to concept of trigonometry. Okay, have a great day. Thank you. If you like the content, please don't forget to subscribe and like my channel. Have a great day. Thank you.